So tonight we're going to talk about factoring polynomials. So whatever page you're on in your journal, the first thing I need you to remember is that factoring is the opposite of distributing, or the inverse. Okay? So when we distribute, like you did on your assignment the other day, if I had 5 times the quantity of x minus 6, then I would go ahead and I would multiply 5 times x, and I would multiply 5 times a negative 6, and I would get 5x minus 30. So that is, we are multiplying here, which is the distributive property. When you're factoring, you're going the other direction. So I would give you the 5x minus 30, and we are going to take out a common factor, or divide. Remember, a factor is a number that we multiply to get a number. So if I'm looking here, I can see that in fact I have 5, and 30 is going to be a product of 5 and 6. So I'm going to take out the 5. It's going to go outside. And when I divide 5 by 5, I'm left with x. When I divide negative 30 by 5, I'm left with negative 6. So you have to think about your GCF here. If I gave you another example of 20x plus 18, well, these are both even. The greatest common factor they have is 2. So I can divide both of these by 2. So my 2 is going outside because that's what I'm taking out. 20 divided by 2 is 10x. 18 divided by 2 is 9. And I know that I did this correctly because if I was to go back through and distribute, I would get 20x plus 18. So we're simply going backwards. When we do this, it can get a little bit complicated the bigger our examples are. So if I have a polynomial of 215x to the third plus 25x squared minus 100x plus 5, well, I can see in fact that all of these are a multiple of 5. So I'm going to divide everything by 5, put that outside, and whatever I have left is going to go inside. So I know that 5 goes into 215 43 times. I'm going to leave my variable x to the third. 5 goes into 25 5 times with x squared. 5 goes into 100 20 times. Make sure you keep your sign, x, and then 5 goes into 5 1 time. So when I factor this polynomial, I have 5 times the quantity of 43 x to the third plus 5x squared minus 20x plus 1. So you simply are looking for the GCF. Now, you can also factor out variables. Sometimes we can factor out whole number factors, but other times we can factor out variable factors. So I know that x to the fourth, 39x to the fourth plus 13x squared, x to the fourth looks like this. I have 4 x's, here I have 2 x's. So I have 2 x's in common on both of these. So I can factor out an x squared. 39x to the fourth over x squared is just 39x squared, because x squared times x squared is x to the fourth. And then I have 13x squared over x squared is just 13. I'm sorry, yes, 13. So we could very well do that. Now, you should also notice 39 and 13 actually have a number in common as well. So we would do better to do 13x squared. So when we do that, 13x squared, 39 divided by 13 is 3. We still have our x squared. 13 divided by 13 is 1. This is the better answer because this has everything factored out. I wanted you to see first, though, that you can take out some variables. Let's try another one with numbers and variables. So we have 6 x squared y plus 3x squared y squared. So in fact, we do have a 3 in common for our numbers. For our variables, they both have x squared and they both have 1y. So I can take out x squared y. So outside, we'll write 3x squared y. And then I can look. So 6 divided by 3 is 2. X squared y divided by x squared y is just 1. 3 divided by 3 is 1. We could write the 1 if we wanted. You don't have to. Unless, of course, everything eliminates. X squared and x squared eliminate. But y squared and y means we just have 1y left. Sometimes we have things that won't factor very nicely. 6x plus 6y plus 7x plus 7y. And this is going to be real important, especially when you get to Algebra 2. You can see that, in fact, there's nothing in common all the way across. So sometimes we need to group. Okay, if I grouped my 6x and my 6y together, and my 7x and my 7y together, now I have a GCF. I have a GCF of 6 on the first parentheses, and I have a GCF of 7 on the second parentheses. So if we group them together, we can, in fact, go ahead and take something out. So I'm going to write it here. I have 6. 6 divided by 6, I'm left with x plus y. If I take out my 7, I'm left also with x plus y. So you are now looking at a second version of this first equation. And you should be able to see, oh, well, I have this term, 6 times the quantity of x plus y, and 7 times the quantity of x plus y. So they do, in fact, have another GCF of x plus y. So I can take x plus y out. When I take x plus y out of 6 times the quantity of x plus y, I'm left with 6. When I take it out of 7 times the quantity of x plus y, I'm left with 7. And now this is factored all the way down. Because if I went back and I did the distributive property, 6x, 7x, 6y, 7y. So right here, if we wanted to factor this, we would get x plus y times 6 plus 7. So I'm going to show you one more of those. And you can submit your answer. I'm not going to do all of the steps. I'm going to let you do the very last step, and you can put it on the form. So if I had 15a plus 15b plus x times a plus x times b. So again, there's not a GCF right here, but if I group, then I can see here I have a GCF of 15 on my first one. So I would write 15 times a plus b. Here I have a GCF of x, and I'm left with a plus b. You should always, when you're grouping, you should at some point end up with the same thing. So now I have a GCF of a plus b on both of these. And I want you to write the final answer here, and that's what you're going to put in your form.